Welcome to my latest project video. Today, I'll showcase a temperature-based fan speed controller built using an Arduino board. This project demonstrates how simple electronic components and programming can create a practical and efficient cooling solution. In this video, I'll walk you through assembling the circuit and programming the Arduino to control the fan speed based on ambient temperature. As the brain of this project is the Arduino, we need an Arduino Uno. First, we get the Arduino Uno, which will be the main controller for our project. I used the Arduino Uno to make this project. Next, we need a 16:2 LCD display to show the visual data on the screen, such as the current temperature and fan speed. The LCD display allows us to monitor the system in real time. Additionally, we'll use a potentiometer to control the contrast of the display, ensuring the text is clear and readable. Then, we have 3 push buttons to navigate the menu on the display. These buttons allow us to control and interact with the data shown on the LCD screen, making it easy to adjust settings and view different information. After that, we need a temperature sensor to get the atmospheric data. Here, I am using the LM35 sensor, which provides accurate temperature readings. Next, I am using a buzzer to alert us when the temperature exceeds the set threshold. The buzzer will provide an audible warning, ensuring we are informed about higher temperatures. Then, I use a MOSFET to regulate the current, which is very useful for controlling the speed of the motor. The MOSFET acts as a switch, allowing us to adjust the fan speed based on the temperature readings from the sensor. The MOSFET's gate pin is connected to the Arduino through series resistors to regulate the current properly. After that, I connected the DC motor as a load. The motor is connected to the MOSFET and ground. This setup allows the motor's RPM to change according to the temperature reading. As the temperature increases, the motor speed will adjust accordingly, demonstrating the effectiveness of our temperature-based fan speed controller. Next, I connected a simple oscilloscope to visualize how the speed is controlled. The oscilloscope is connected to the output of the MOSFET and connected in parallel to the motor. This allows us to see how the pulses are controlling the current, with the data also shown on the LCD display. This setup provides a clear view of how the temperature readings influence the fan speed through pulse width modulation. Now, it's time to move towards the coding part, which is the most important aspect of our project. The code link is provided in the description below. This code is very simple and easy to understand. It includes all the necessary instructions to read the temperature data, control the fan speed, and display the information on the LCD screen. With all the circuit and coding parts ready, it's time to simulate the project and see it in action. We'll use the Walkwi online simulator to test our temperature-based fan speed controller. By running the simulation, we can observe how the fan speed adjusts based on the temperature readings, and how the information is displayed on the LCD screen. We can observe how the fan speed adjusts based on the temperature readings. As the temperature changes, the speed of the motor changes accordingly. The graph displayed on the oscilloscope shows how the pulses are controlling the current. If the temperature exceeds the set limit, the buzzer will activate and provide a warning. This ensures that we are alerted to high temperatures and can take necessary action. Conversely, if the temperature is below the set value, the fan will turn off to conserve energy. We can change the setting of the set values with the help of push buttons. When we press the first push button, we enter the menu for setting adjustments, which displays the higher set limit and lower set value. The second push button is used to increase the temperature value, while the third push button is used to decrease it. This feature allows us to easily customize the temperature thresholds for the fan and buzzer activation according to our needs. With these adjustments, we can fine-tune the system to respond to specific temperature ranges, providing flexibility and control over the fan speed and warning alerts. Thank you for watching. I hope you found this video on creating a temperature-based fan speed controller using Arduino insightful and enjoyable. If you liked what you saw and learned something new, please consider giving this video a thumbs up, it really helps out the channel. Make sure to subscribe and hit the notification bell so you don't miss out on future projects and tutorials. I'm always exploring new ideas and technologies, so stay tuned for more exciting content. Feel free to leave any questions or comments down below. I'd love to hear from you and help out however I can. Thanks again for your support, and I look forward to seeing you in the next video. Happy tinkering!